the roots. So your roots of a polynomial function is the same thing as your solutions, which is the same thing as your zeros, which is the same thing as your x-intercepts. So we've got a whole bunch of ways to describe what these numbers are. They're the roots, they're the solutions, they're the zeros, they're the x-intercepts. It's all of those things. So if you are asked to find the roots, that's the same thing as being asked to find the zeros. If you're asked to find the x-intercepts of the graph, that's the same thing as the zeros. If you're asked to find the roots, it's the same thing as the x-intercepts. It's all the same. It's just different words used for it. Now, sometimes you have roots that occur more than once. And we kind of touched on this back when we were graphing, but I want to touch on it again. We use that word multiplicity. So if something is occurring more than once, it's going to have a multiplicity of whatever number it would be. So if you see the word multiplicity, or if you write the word multiplicity, what you are stating is the number of times a zero occurs. Okay. So, for example, if I go back to Desmos, while you guys finish writing that up. Does everybody have that? Yeah? Good? Get rid of it? All right. So if I were to graph the equation y equals x plus 1, what's the degree? 1. Okay, so is that even or odd? Odd. Does your left and your right behavior make sense?
Sure.
Yes. What is the zero of that factor? -1. So that makes sense that my solution here is at -1, my zero. If I were to square this, now I just turned my polynomial into a degree of what? 2, which makes it even, right? So does that make sense with your left and right behavior? Yeah. Did your zero change? No. My zero still stayed the same, but now since it's a degree of 2, what's happening is that zero, or that -1, is getting a multiplicity of 2, meaning that's occurring 2 more times. What would change in this graph if I were to change the squared to a cube?
The AP law, Ling law.
So it would turn into an odd function, right? Did the zero change?
No.
No. Now it just means that it's occurring how many times? 3 times. So now it has a multiplicity of 3. If I change it to a 4, here's my new graph. Did my zero change?
7.
No. I changed it to a 7. Did it change? 9. Did it change? 11. Did it change? 21. Did it change? 53. Did it change?
I like that one.
Now it's like really flattening it out, right?
I did that on purpose.
You did that on purpose? Favorite function right there?
Yep.
Okay, so you notice how the larger we get, the flatter it's getting at that 0, right?
Can you do it?
If I do it for evens, so 6, 22, 54, just keeps flattening out, 102, but the 0 is still staying the same. If I zoom in on that, keep zooming in, oops, I can't zoom in any further, okay, it only gets to that 0 right there. If I come here, it still is getting closer to -1, I guess it is at 0 there, huh? Okay, so, multiplicities, does that make sense? Got multiplicity? Yes, yes, yes. So, what would be the zeros of this polynomial function? So the zeros of this polynomial function, here I would have a 0 of 0. I would have a 0 of 2 with a multiplicity of 3. And this is what you are going to need to write out. you're going to need to state, I have 2 with a multiplicity of 3.
I just write 3 too.
Nope. And then my last 0 is occurring where? -1 with a multiplicity of 2. What would be the degree of that polynomial if we multiplied it all out?
Ten.
6.
It would be 6, right?
Yeah.
Because I've got 1, 3, and 2. Add those together gets me to 6, which means it would be an even. Would it be positive or negative? So it would be going up or going down? It would be going up, right? Okay. Where are your 6 zeros? Well, I've got 2 of these. I got 3 of these. And I got 1 of those. So that makes what? 5. That's 6, right? If I could add right, that'd be good. So that got you to your 6. Avery, question.
The x, when it's like 3x, does it change from 0? Or is
Nope, it would just be 0. So, and whenever you have that monomial out in front, it will always be 0. Because if I had a 3 here, 3 times 0 is still 0,
Oh, okay.
right?
Yeah. Gotcha.
It's only when you have the plus or the minuses in there where you have to kind of think backwards. All right, so we can do this, yeah? So now we need to make sure we can get it to look like this. And this is what we're going to learn how to do using synthetic division. So hopefully we remember our synthetic division. So we're going to use a graph to cheat, synthetic division, and then factoring to find all the roots, otherwise known as all the solutions, otherwise known as all the zeros, otherwise known as all the x-intercepts of this polynomial function. Okay? So, we're going to use that synthetic division. If I were to set up my synthetic division now, I would have my half box. What would be my coefficients? 1, I got a cubic. What's my quadratic? -7. I got a linear. 15. I got my constant, -9. So now the question is, what goes in the half box? In the past, they told us, divide it by this. Divide it by x plus 2. If I divide it by x plus 2, what went in the half box?
Negative.
Right. If it was x minus 1, what went in the half box? Plus 1, right? So now this is where we're going to cheat. In section 7.5, we're going to learn a theorem
How to cheat?
on how to not cheat. But today we're going to cheat. So you need your graphing calculator in hand. I want you to graph that function in your y equals screen.
I used the graphing technique thing on the SAT.
Did you?
Yeah, because I had to graph something.
Nice.
I attempted it, but I did the wrong question.
I didn't know how to get to like the L1, L2, L3 screen. I forgot because I think I only
The
used
stat, yeah, probably. All right, so x to the third minus 7x squared plus 15x minus 9. All right, I'm graphing mine on Desmos, so it's a little bit easier to see than probably on your graphing calculator. All right, so are you guys getting something that looks like that? Now remember what you can do to check to see if something is a 0 using your graphing calculator. If you hit your trace button, I mean here it's obvious on mine that 1 is an x-intercept. If you hit your trace button and hit 1, does it come up with 0 as the y?
Wait. Trace.
If you hit trace 1.
Hit trace
Y equals 0.
and then type in 1 for the x. Does it get you an output of y being 0?
Yes.
And then you should also see that there looks like there's another one occurring at 3, right? So if you did the same thing with 3, trace 3, it should come up with 0. Well, what was our starting degree of this polynomial? Cubic, right? So that technically means I would need to have 3 factors if I were to factor that, right? If I have 3, my degree of 3, that means I need 3 linear factors. But I only have 2 zeros. So that means what?
That there's multiplicity
one of them is going to have a multiplicity of 2 for it to add up to 3, right?
Okay.
Do I know which one?
No.
No. Okay, so now we're going to have to use some synthetic division to figure that out. So, which one do you like better, 1 or 3?
1. Oh no.
3.
No, 1.
You want to use 3 for synthetic division? Let's use 1. Let's use 1. All right, let's put that 1 into our half box. Now, keeping in mind, if 1 is a 0, flip your brain backwards, what would that look like as a linear factor?
X minus 1. X minus 1.
It would be x minus 1. So I'm just going to make a little side note over here. So I remember that this solution of 1 really means I have a linear factor of x minus 1. Okay? So that's going to be one of my linear factors when I go to factor this polynomial. Now let's go ahead and find the rest. How do we do synthetic division? What do we do first? Bring down this first 1. 1 times 1 is 1. What do I do with the negative 7 and the 1? So I get negative 6. Multiplying gets us negative 6. Adding gets us 9. Multiplying gets us 9. Adding gets us 0. Remainder of 0. Isn't that nice?
That's crazy.
When we input and traced 1 on our calculator, what was the output? 0. So that means that that had to be a 0 because we did it right. Okay, so now, what does this end up looking like as a polynomial?
X squared minus 6x plus 9.
So now I'm left with x squared minus 6x plus 9. Now we just went from a cubic polynomial to a quadratic polynomial. Do we know how to solve quadratics? Hopefully. Factors of 9 that add up to negative 6.
3.
Negative 3 and negative 3. So which one's going to have the multiplicity, do you think?
3.
Right. So what does this look like in full-out factored form?
It's gonna be that.
So I'm going to erase this part so I can get higher up for those in the back. So this polynomial really factors to, remember we said our first 0 was 1, so that means one of my linear factors was x minus 1. My other 2 we just discovered was x minus 3, x minus 3 equals 0. So find all the roots, i.e. find all the zeros, find all the solutions. So what are my solutions? What am I going to say? X equals what? 1 and then 3 with a multiplicity of 2. Okay? So it's important to have your graphing calculator. If you don't have a graphing calculator and you have the internet, pull up Desmos, you can graph it there. But you're going to want to have access to graphing these for your homework and for the quiz on Friday. So make sure you have your graphing calculator with you. Let's do one more. And that's it. Got it? All right.
This is gonna be a quiz on Friday.
What just happened?
Yeah, our quiz is on 7.4.
So x to the third plus 3x squared minus 4. There's our polynomial.
I wouldn't imagine that'd be on the quiz.
Let's get our synthetic division set up. Empty half box. What are going to be my coefficients? 1. Be careful.
4.
What should come before the negative 4? 0. And then negative 4. Why do I need a 0 there?
Because the linear.
Did I miss the recycling? Because there is no linear. Good. All right. Get your graphing calculator out. I might have missed recycling. Let's see what that looks like as a graph. So my graph's ending up like.
No, that's nothing.
Why is that 0?
No, actually.
You think it's the -2 doubled?
It's the 2 because that's when it bounces off the negative. It bounces off the number. That's the
When it's occurring more than once. All right, so which number do you want to use for synthetic division? 3 is not even an option. 1. Bring down your 1. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4. 0 plus 4 is 4. 1 times 4 is 4. Remainder is 0. So now I have x squared plus 4x plus 4 is equal to 0. Factor that.
Wait, what about that?
X plus 2.
Oh, I keep forgetting to put the negatives.
2 and 2?
Yep.
X plus 2. X plus 2 equals to 0. So
No.
what are my roots?
-2 and -2. Nope.
2 and 2.
Twice and then 1.
Right. So this in factored form was what? X minus 1 and then x plus 2 squared, right? Technically in factored form. So I have a solution of 1 and -2 with a multiplicity of
7.
2. Yes.
I'm still confused on how you got the 1 for the.
So that's one of your x-intercepts. So when you graph it, it should be crossing the x-axis at 1.
Always?
What
No,
if
not
I
always.
didn't get that? What if I got it crossing at like?
Recheck how you typed it in. Is it the same function?
Yeah.
X to the third plus 3x squared minus 4.
Yes.
X to the third plus 3x squared minus 4, right? Should be at 1 and -2. Do a zoom 6. Did it make it look different?
Yeah, I can only see half of it.
If you did zoom 6. All right, grab yourself a practice space.